Have you ever been driving on a hot day and seen what looks like a pool of water on the road ahead, only to find it vanishes as you get closer? That, my friends, is a mirage. It's a fascinating optical illusion, a trick of light that our brains interpret as water reflecting from the ground. But the truth, as with many things in the universe, is far more intriguing than it initially appears. Mirages are not figments of our imagination. They are real phenomena, just like rainbows and sunsets. They are formed by the bending of light rays, a process known as refraction, which occurs due to differences in air temperature. While we often associate mirages with deserts, they can occur in various locations where there are significant temperature gradients, such as over bodies of water, snowfields, and even hot asphalt roads. But how exactly do these temperature differences create such convincing illusions? To understand that, we need to delve a little deeper into the science of light and refraction. Imagine light as a traveler on a journey, its path not always straight, but susceptible to bends and turns depending on the medium it's traveling through. When light passes from one medium to another, say from air to water, it changes speed and direction. This bending of light is what we call refraction. Now let's apply this to mirages. On a hot day, the ground absorbs heat from the sun, making the air layer closest to it much hotter than the air above. As light travels from the cooler air above towards the hotter air near the ground, it encounters this sudden change in temperature, which acts like a different medium. The light rays bend away from the normal, the imaginary line perpendicular to the surface, causing them to curve upwards. Our brain, however, is accustomed to light traveling in straight lines, so when these bent light rays reach our eyes, our brain interprets them as if they have traveled in a straight path, creating the illusion of an object being reflected in a pool of water. Mirages are not one-size-fits-all illusions. They come in different types, each with its own unique characteristics and formation mechanism. The most common type is the inferior mirage, the classic desert mirage, where we see an illusion of water on the ground. It's called inferior because the illusory image appears below the actual object. Then there's the superior mirage, which occurs when the air near the ground is colder than the air above, such as over a cold body of water or ice. In this case, light rays bend downwards, making objects appear higher than they actually are. This is why ships sometimes appear to be floating in the air, a phenomenon known as fata morgana. These are just two examples, and there are other, rarer types of mirages, each showcasing the fascinating interplay of light and atmospheric conditions. Mirages, while seeming like extraordinary events, are actually more common than we might think. Ever noticed a swimming pool appearing shallower than it really is? Or a straw seeming to bend in a glass of water? These are everyday examples of refraction, the same phenomenon that gives rise to mirages. Understanding mirages is not just about appreciating the wonders of nature. It has practical implications too. For instance, surveyors and astronomers must consider the effects of refraction while taking measurements. Pilots need to be aware of how mirages can distort their perception of the horizon. So, the next time you're driving on a hot day or gazing out at the vast expanse of the ocean, keep an eye out for these fascinating tricks of light. Mirages remind us that the world is not always as it seems, and that there's always more to discover, even in the most seemingly ordinary phenomena.